Hey guys, today we are going to talk about limits with infinity. So if I'm looking at example 1 right here, we've got the limit as x goes to infinity of this function. So as we're going off to infinity this way, we can see that the graph is going to get closer and closer and closer to 1. So our limit is going to be 1 for example 1. Then if I'm looking at 2 right here, I'm looking for the limit as x goes off to, that's supposed to be a positive infinity, as x goes off to positive infinity. So you can look here, and as we're going off to positive infinity, so is our y value. So this limit does not exist because we're going off to a positive infinity. For example 3, as we're going to negative infinity. So as we're going to negative infinity over here, we're getting closer and closer to 0. Then as we're going to positive infinity here, we are getting closer and closer and closer to 3. For number 5 here, as we're going off to infinity, we're getting closer and closer and closer to 0. And here, as we're going to negative infinity, this one is also going off to negative infinity. So this limit does not exist. So there are a couple patterns here that we are going to talk about. So which functions have a limit of does not exist? So the does not exist is number 2 right here and our number 6 right here. So I'm going to say the limits that go off to infinity or negative infinity that do not exist is the limit as x approaches infinity for my x squared minus 4x plus 4 over x, and the limit as x goes to infinity for our x cubed plus 4x squared plus 4x all over the x squared plus 2x minus 8. All right, the next one asks which one have a limit of 0. So our 0 limits are number 3 right here and number 5. So I'm going to write that over here. It's the limit as x approaches negative infinity of 1 over x cubed minus 1, and the limit as x approaches infinity of 1 over x minus 1. And then the last one says what function has a limit of a number not equal to 0. So that is our example 1 right here. We got a 1. In example 4, we got 3. So that was the limit as x approaches infinity of our 3x cubed over 3x cubed plus x squared minus 4x. And the limit as x approaches infinity of 3x squared minus 1 over x squared. So some of you may have seen the patterns, some of you may not have seen them yet. So if I'm looking at this one right here, I've got x squared over x and x cubed over x squared. So if you remember our horizontal asymptote rules, this one, it has a higher exponent over a lower exponent. Let's write that so it actually looks like an H. Sorry, guys. So we've got high over low. So then our next one here, we've got low over high. And our last one, we have same over same. So what rules can be used when the limit of a function is approaching positive or negative infinity? Our horizontal asymptote rules. And remember, our horizontal asymptote, if you remember from Frady, it's the E, which stands for the end behavior of our graph. So that kind of makes sense because our end behavior is looking as our graph goes off to infinity and off to negative infinity. What's happening to our graph? So it makes sense that those horizontal asymptote rules can be used to find our limits as we're going to infinity and negative infinity. So there are some exceptions or some loopholes. So let's look at how the horizontal asymptote rules apply if x is in the exponent instead of it being a normal polynomial as seen on the last page. So if I'm looking at number 7 right here, as we go off to infinity, it's going to 1, and then as we go off to negative infinity, it's going to a negative 2. And then for 8, as we're going off to infinity, it's going to 0. And as we're going to negative infinity, it's going to 1. So what you're going to do here is as x approaches infinity, you're going to look at the exponent part, and you're going to use your horizontal asymptote rules. So right here we have same over same. It's 2 over 2. So that's going to lead us to 1. So as x approaches infinity, it goes off to 1, just like we said. And then when you're going to negative infinity, you're going to use the part without the x. So you're going to use this part right here. And so that one is 2 over negative 1, which gives us a negative 2, which is what we're going off to over here. And so that's going to work for 8 as well. As x goes to infinity, we're going to use our horizontal asymptote rules. So I have low over high, so 0 equals y, and it's going off to 0. And as x goes off to negative infinity, we look at the part without the x. Oh, let's rewrite that so it actually looks like a word. And so we're going to look at the 1 over 1 right here. And that's what gets us going towards 1 as we go to negative infinity. So let's look at some examples here. Okay, so number 9, we're going off to infinity. So we're going to use our horizontal asymptote rules. So that does mean that we need to FOIL out the bottom of our fraction. So I'm going to have the limit as x goes to infinity of x over first times first gives me x squared, outside times outside is minus 3x, inside times inside is plus 3x, and last times last is minus 9. So I am looking at low over high. So 0 equals y. So our limit here is 0. And let's look at 10. This one we're going off to infinity. So we're going to use our horizontal asymptote rules. We've got the same over same. So we're looking at 1 over 1, which is just going to give me 1 because we have same over same. All right, number 11, we're going off to negative infinity. So let's go ahead and FOIL out the bottom right there. So the limit as x approaches negative infinity of x squared over, well, 3 times 3 is 9, plus 3x minus 3x minus x squared. So we're looking at same over same. So we've got 1 over negative 1. So we're going to end up with negative 1 for our answer for our limit for number 11. And let's look at 12. So for number 12, we're looking at the limit as x approaches negative 2 from the negative side. So we're not going to use our horizontal asymptote rules because our limit is not going to infinity. So what we're going to do here is we're going to make our table like we have in past videos. So I'm going to have my x, I'm going to have my f of x, and so I'm looking at negative 2 from the negative direction, so I'm going to do negative 2.1, negative 2.01, and negative 2.001. So I'm going to pause here and let you guys plug those into your calculator on your own. And then once you've done that, we are going to pick back up. Okay, so when you plug this into your calculator, you should get a negative 4.1176, negative 40.1197, negative 400.1197. And so you can see that this is going off to negative infinity. So that is what our answer is going to be. And this is a does not exist limit. We're going off to negative infinity. Okay, let's look at number 13. Once again, our limit is not approaching infinity. It's looking at 0, so we're going to have to do a table. I've got x and f of x, and I'm looking at 0 from the positive. So I'm going to do 0.1, 0.01, and 0.001. So you guys plug those into your calculator, and let's see what you get. All right, you should get 50, 500, and 5,000. So you can see that this is going off to positive infinity. And this is a does not exist limit because it's going off to positive infinity. For number 14, once again, we are not looking at the limit going to infinity. We're looking at x going to 0, this time from the negative side. So I'm going to create my table, x and f of x, and I'm going to use negative 0.1, negative 0.01, and negative 0.001. So I'll give you a second to plug this into your calculator, and then we'll continue. All right, when you plug these in, you should get a negative 30, negative 300, and negative 3,000. So this one's going off to negative infinity. And once again, it's a does not exist because it's going off to infinity instead of a number. All right, for 15, we're looking at the limit as x approaches infinity. So we can use our horizontal asymptote rules. Notice that we're not looking at a polynomial. We're looking at where x is in the exponent. So remember, as x goes to infinity, you're going to use your horizontal asymptote rules. And as x goes to negative infinity, you look at the part without the x. All right, so we are going to positive infinity, so I'm going to look at this part right here. We've got same over same. So our coefficients, and it's 1. And let's look at 16. This time the limit is going to negative infinity, and x is in our exponent, so we're going to look at the part without the x. So I've got a negative 3 over 1, which is just going to give me negative 3. So my answer for 16 is negative 3. All right, that's all for today's notes. Make sure that you do the 1.5 worksheet, and you guys have a good day.